Okay, let's get into this. We're looking at something really foundational in Node.js today.
Yeah, absolutely. How it handles binary data.
Right, because when you're working with, say, images or network stuff or even files,
hmm
it's not just strings, is it? You have to deal with the actual raw bytes underneath.
Exactly. And that's where buffers come into the picture in Node.
Buffers. Okay.
Think of them as a special way Node has to hold these chunks of raw binary data right in memory.
So kind of like an array, but specifically for bytes.
Sort of, yeah. They help bridge the gap between, the text we usually work with in JavaScript and the actual ones and zeros the computer uses.
And understanding them is pretty important for anything involving I/O, right? Input,
Uh,
output.
oh, absolutely crucial. They're everywhere once you look under the hood.
So you said they're like arrays, but what makes them different? Why not just use a standard JavaScript array for bytes?
That's a great question. They might look a bit like arrays sometimes, accessing elements with square brackets.
Buffer zero, that kind of thing.
Exactly. But a really key difference is that buffers have a fixed size. Once you create one, that's it. You can't just grow it dynamically.
Ah, okay. Unlike a JS array where you can just push things on.
Precisely. And this fixed size, plus the fact that they give you direct access to a block of memory,
Hmm.
memory that's often outside the normal JavaScript V8 heap.
Outside the usual garbage collection loop.
Yeah, that's what makes them efficient for low-level stuff. It's about performance and talking directly to system resources.
Okay, fixed size, direct memory access feels a bit more low level than typical JavaScript. So how do we actually, make one safely?
Right, safely is the key word. Node has improved this over time. The main way now is buffer.from.
Buffer.from.
Yep, you can give it a string like hello, and very importantly, specify the encoding, like at F8.
So buffer.from hello AF8 would give me the actual UTF-8 bytes for hello.
Exactly that. It creates a buffer with those specific bytes. You could also use buffer.from with an array of numbers where each number is a byte value, or even copy another buffer.
Okay, simple enough for creating from existing data. What if I just need an empty space? Like, I know I need 50 bytes to receive some network data into.
Good scenario. For that, you use buffer.alloc.
Alloc, like allocate.
Exactly. You
Yeah.
just tell it the size, say buffer.alloc 50, and it gives you a 50-byte buffer.
And it's just empty.
Well, here's the crucial part about alloc.
Hmm.
It initializes that memory. It fills it all with zeros.
Fills it with zeros. Why? Seems like extra work.
It might seem like it, but it's a really important security feature.
Yeah.
It prevents you from accidentally reading old leftover data that might have been in that memory location from, well, who knows what.
Wait, so memory might just have old data hanging around.
It absolutely can, which leads the other way. Buffer.alloc-unsafe.
Uh-oh. Unsafe. Never sounds good.
Well, it has its place, but you have to be careful.
Hello.
Alloc-unsafe is faster precisely because it doesn't do that zero filling step. It just grabs a chunk of memory.
So it could have anything in it.
Potentially, yes.
Hmm.
Anything left over from previous operations. You should only use alloc-unsafe if you are absolutely 100% certain you're going to write over every single byte of that buffer immediately after creating it.
Otherwise, you risk reading garbage or, worse, sensitive data.
Exactly.
Hmm.
It's a performance optimization, but with a real risk. That's why the old buffer constructor is gone. It was too easy to accidentally use it unsafely. Stick to buffer.from and buffer.alloc.
Wow, okay, point taken. Use alloc unless you really, really know what you're doing.
So we've got our safe buffer.
Hmm.
How do we get data out or put data in?
Reading is simple. Like we mentioned, you can access individual bytes using bracket notation in my buffer index. That gives you the byte value in integer from 0 to 255.
Okay. And getting it back to a string.
Use the toString method. So my buffer.toString, and again, you usually want to specify the encoding, like my buffer.toString, UF8. You can also slice it first to only convert part of the buffer.
Right. And writing into it, let's say I used buffer.alloc100 and now want to put hello starting at byte 10. For that, you use the write method, .mybuffer.write.
Okay.
It's pretty flexible. You give it the string, like hello, then optionally where to start writing the offset, so 10 in your example. You can also specify how many bytes of the string to write and the encoding.
So you can precisely place data within the buffer. Useful for network protocols or file formats.
Totally. Think about building a network packet header. You'd use write with different offsets to put the version number here, the payload length there, all into one pre-allocated buffer.
Makes sense. What about just working with parts of a buffer? Like if I only care about bytes 20 through 30.
That's where slice comes in, my buffer.slice 20. But here's a really important detail. Slice. creates a new buffer header, but it points to the same underlying memory as the original buffer.
So it's not a copy. If I change the slice, I change the original.
Exactly. It's super efficient because it avoids copying memory, which is great for performance, especially when parsing data streams. But you need to be aware of it. If you modify the slice, the original buffer reflects those changes.
Okay, so slice is like a view. What if I actually want a separate copy?
Then you need copy. You typically create a new buffer with buffer.alloc and then use original buffer.copy, target buffer, to copy the bytes over.
Got it. And combining buffers if I have two small ones.
Buffer.concat. You pass it an array of buffers like buffer.concat, buff1, buff2, and it gives you a new, larger buffer with all the data joined together.
It really sounds like buffers are just the fundamental way Node deals with any kind of raw data. Files, network sockets, crypto.
Pretty much anything that involves sequences bytes, yeah.
Okay.
They provide that necessary layer for efficient I/O, bridging JavaScript with the underlying system operations.
Yeah.
Understanding them, especially their fixed size and how memory allocation works.
And the slice versus copy distinction.
Right. It's key to avoiding bugs, especially when you're dealing with streaming data that comes in chunks. Mismanaging buffer offsets or sizes there is a classic problem area.
Okay, so summing up. Buffers are Node's way to handle raw binary data, fixed size, direct memory access. Crucial for I/O.
Yep. And remember, to create from existing data, buffer.alloc for safe, zero-filled allocation.
And be very careful with alloc unsafe. Then use methods like toString, write, slice, copy, and concat to work with them.
That's the core of it. They're foundational.
It definitely makes you think. If strings are for text and buffers are for raw bytes in Node, where else in programming, maybe outside NodeJS even, are we implicitly working with binary data without maybe realizing it?
That's interesting.
And where could really understanding this byte level stuff give you an edge, maybe solve a weird bug or find a neat optimization, something to think about?